Right guys, let's have a look at question 1a then on this M1 paper. It's very verbose, the first question actually, but all it does in part A is, I put it all up here, but all it does in part A, it asks for, let me just read it to you, part A. It says, draw a sketch of the velocity time graph showing the motion of the train between A and B. So we need to draw a velocity time graph, so that's why I've drawn this velocity against time axis here at the bottom. And here's the bump, what it says. So let's have a look and fill in this velocity time graph, shall we? To do 1 part A. Starts at rest from A. So when t is 0, it's at rest, so v is 0. So there's our first coordinate, and that's where it is at A on this velocity time graph. It goes to B. On leaving A, it accelerates at a constant rate for 60 seconds. So 60 seconds along, which I'll put here, right? At 60 seconds along, until it reaches a speed of 30 meters per second. So at 60 seconds it's going to reach this speed, and that would be 30 meters per second. So let's put that in there. And that would be a point X, correspond to a point X. It continues at this speed to a point Y. So it's going to go along. Let's just draw it in then. So it's accelerated uniformly at a constant rate there. Then it went along horizontally to a point Y, which we don't know where it is. So I'm just going to draw it like that, say. And that's the point Y then. That would be the correspond to the point Y, wouldn't it? So let's suppose it's there then. That's where we are so far. When a constant, so here, a constant deceleration is applied for 40 seconds. So whatever time this is, we need to add on 40 seconds. So this distance here is 40. Yeah? And so what happens? So that the speed of the train at B, which is where it's going to finish its journey, is 15 meters per second. So let's put in 15 then. And it's going to finish its journey at 15 meters per second by decelerating for the last 40 seconds. So it's going to end up there, isn't it? So let's draw the straight line between those two things then on the velocity time graph. Those two coordinates. Okay. So I think that's it. So we don't know the time here, but we know this distance is 40 seconds. So we can start filling that in then, can't we? So let's suppose that we draw the time. That would be the total time then, and this would be t minus 40, yeah? Okay, so I can get rid of this little 40 now that I put in just to help me to see what was what. Okay. And I can put t minus 40 here. And that's the last 40 seconds, wasn't it? So there's our velocity time graph, and that completes part 1A of the question. Okay, good. Let's go on to the next one. Great.